Okay, we have a solubility equilibrium question, which is basically the same idea as the last question on equilibrium 2. Um, you can find that on our website. But the idea with the solubility equilibria, just reading this question that I've done up as a sample, it says the compound of lead 2 net chloride is insoluble in water. The equilibrium constant for the dissociation of lead chloride in water is 1.6 times 10 to the negative 5. So the first thing that we're going to have to do is we're going to have to write the dissociation equation for this. So we know that lead chloride is PbCl2, and we know that it is a solid because we're going to dissolve it into water. We know that it's going to reproduce um, two ions, lead 2 and chloride minus 1. Since there's two chlorides in the ionic formula, we're just going to make sure that we make the stoichiometry work, and then we write our equilibrium expression. So what we really expect to be happening is we expect that we have this ionic solid that kind of looks like this, and above it is, of course, the solution of the water. And it is very sparingly soluble. We know from one of our earlier units that when chloride interacts with lead, it becomes forms a precipitate. Well, the reality is that the water molecules themselves, little triangles, or they'll actually surround these ions a little bit, carry them away. But for every one that does that, one of the ions will be replaced. So from our perspective, it doesn't really look like anything's happening. So these compounds, because they're ions, they have to be aqueous. I'm just going to note that in green. So the next thing that we do is we write the equilibrium expression for the process. So we can write Kc. We will learn that there's a better sub for that. It's called Ksp, or the equilibrium constant for the solubility product, or Sp. And it's equal to the concentration of the products, Pb plus 2, raised to their exponent, so I have a 1, over the reactants. But since the reactants are solid, we don't include them, so we just have the product of them, hence the solubility product. So question C says, why is the reactant in this process not written? We can just write it is a solid, which is never included in equilibrium expressions, of course. So what is the concentration of chloride ions present in the saturated solution of lead chloride? So we can do this, we can write this all the way out if we want to make our lives a little bit clearer, hopefully. We write our icebox out. Wish I had a ruler, but because this is a solid, we're never going to include it. So I wrote it in as just so we could see where the equation's coming from, but we're only going to be concerned in these two areas. So the concentration of lead, and chloride, when we start, is nothing. So we've dissolved some of this lead chloride in solution, and now it's starting to form ions. Well, the stoichiometry says that for every 1 mole of lead, there must be 2 moles of chloride. So we know that these are being produced, so they're positive, and we write x and 2x in our equilibrium line. Starting from 0, so plus x, starting from 0 plus 2x, and I think we should be good to go. So finally we write Ksp is equal to 1.6 times 10 to the negative 5 is equal to x times 2x squared is equal to x times 4x squared is equal to 4x cubed. And of course we have that constant that's just going to keep following us down. So end up with 1.6 times 10 to the negative 5 is equal to 4x cubed. So x cubed is equal to 1.6 times 10 to the negative 5 divided by 4. X is equal to the cube root of, let's just take the cube root of it, this whole object up here. So what we're going to do is we're just going to solve for that 1.6 exponent 5 negative divided by 4. So we get 4.4 times 10 to the negative 6. When we divide that by 4, we take the cube root of that, and I get 0.015874. And these are of course going to be in moles per liter. What that means is that if we have a saturated solution, we're never going to, it does not matter what is going to be, what the initial concentration of lead chloride is, because it doesn't appear in our icebox. So the concentration of lead plus 2 is just going to be equal to x, because that's what we solved for. So 0.01, and I only have two significant figures in my KSP constant, so I'm just going to stick with that, molar. And the concentration of the chloride is going to be equal to double that, so 0.032 molar. So when we look at these questions, it's really important to remember that you're talking about a dissociation. Because it's a sparingly soluble, or from back in the first of the course, we talked about insoluble. We write the backward, the two-way arrow indicating an equilibrium. We can write the equilibrium constant, Kc, which in a specific case, because there is no denominator, and we're talking about solubility, we use Ksp. And the reason the reactant doesn't appear is because it's a solid. And then we can just use our icebox to figure out the concentration of the ions present in solution. And that's a very small number, so we would basically say that is insoluble. I hope this helps.